In this video, I thought I'd go over a few examples of how to solve first-order differential equations through the method of separation of variables. So in this first example, we have the derivative of y with respect to x is equal to sine of x all over e raised to the y. In this first example, what we first want to do is we want to separate our variables of x's and y's. So here we have e to the y dy. And I got this by multiplying both sides by e to the y. Let me go ahead and show that. Here we're still left with this dx right here. So we'll go ahead and just multiply both sides by dx to get rid of this dx on the bottom. Separation of variables is nice because it feels more so like a puzzle that just needs to be put together in order for you to solve it. As you'll see in later videos, some methods of solving differential equations can be quite tedious. From here we have our two variables separated, so we have all our y's on one side and all our x's. Oh, my bad. All our x's on the other. So what we're going to go ahead and do is we're going to go ahead and integrate both sides. Once we integrate both sides, the integral of e to the y dy is just e to the y. The integral, let's see, the integral of sine of x is negative cosine of x. Let's see. From there, we can just go ahead and we can combine our constants. So we're left with e to the y is equal to negative cosine of x plus c. From there, what we want to do is just to get y alone so we can actually solve for our independent variable. We can raise both sides to the natural log. So I'll take the natural log of the left-hand side, and we'll take the natural log of the right-hand side. From there, what we're left with is just y is equal to the natural log of negative cosine of x plus c. From here, we can do, I have another example. Go ahead and choose a different color here. This example, we have the derivative of y with respect to x is equal to x times y squared divided by 8 plus y squared. From here, the first thing we want to do is to see if we can separate our variables first. So first thing I want to do is I want to go ahead and multiply out this x times y squared. If I do that, what we end up with is dy over dx is equal to x squared times y squared. Right, I just did x times y times x times y. It gives me x squared times y squared plus y squared. From here, we can multiply both sides by dx right here and right here. So now what we're left with is dy is equal to x squared times y squared divided by 8 plus y squared. This is all being multiplied by dx. So now what you'll notice is we still have some y's over here. Well, what we can do is we can go ahead and we can pull out these y squareds right out of this equation, right? So we can pull this y squared because this variable right here, this term has a y squared and this term has a y squared. So go ahead and pull a y squared out of both of these. So what we're left with is x squared divided by 8 plus 1 all times dx. Now what we can do is we can divide both sides by y squared. And divide both sides by y squared. So we can go ahead and divide this side by y squared and go ahead and divide this side by y squared. Now, so move our work over here. What we're left with is 1 over y squared times dy is equal to x squared divided by 8 plus 1 all times dx. Now this is something we can actually integrate, right? Because now we've separated our variables. Now we separated our variables into two separate terms, so only containing either x or y. So now what we can do is we can integrate. So let's integrate this left-hand side and this right-hand side. So for the integral right here, what we can do is we can change our exponent's power, right? So since we have 1 over y squared, we can rewrite that as y to the negative 2 times dy. And this right-hand side, what we can do is we can go ahead and we can separate this into two separate integrals. So we can have 1 over 8 x squared. That's this term right here. I just took the 1 over 8 out and just make it, just for a visual sake, times dx plus the integral of dx. Right, so all I did was separate this into two separate integrals, right? From here, we can do the integration of the left-hand side. So the integration of the left-hand side, we're going to go ahead and we're going to add 1 to the power divided by a new power. Add 1 to the power, this would be y to the negative 1 divided by the new power, which is negative 1. So we're going to have, oh, I don't know why I wrote that integral. We're going to go ahead and write y to the negative 1 divided by our new power, which is negative 1 plus c. From here, we're going to integrate our right-hand side. And our right-hand side, we can go ahead and take out this constant right here. Remember, we're going to do the same thing. This may be positive, but it follows the same rule. So we're going to add 1 to the power, which is x squared. So it becomes, we're going to have a third power now and divide by the new power. So we're going to have 1/3. So all I did was add 1 to the power, divide by the new power. We integrate this right here. So the integral of dx is just x. Remember, add our constant c. From here, we can combine our constants. So we're left with negative 1 over y is equal to 1/8 times 1/3 is just 1 over 24. 1 over 24 x to the third plus x plus c. So we just combined our constants from here. From here, let's try to get this all over one denominator. Right? So if we do that, what we can do is we can do x to the third plus x plus c all over 24. Oh, my bad. So x to the third. So we want to get this over 24. So that's going to be 24x over 24, right? We haven't changed anything. We just changed the appearance of our variable. And same for this c right here. So this is going to be plus, well, 24c is just c. So we can just go ahead and put that over 24, right? 24c over 24. If we multiply this c by 24, it's just another constant. From here, now we can actually multiply both sides by negative 1. Negative 1 on both sides. And we can take the reciprocal. We can take the reciprocal of both sides. So let's go ahead and do that. So if we multiply both sides by negative 1 and take the reciprocal, what we're left with is negative 24 over x to the third plus 24x plus c. And just one more example to hammer in the point. More simpler example than the last one. let's say we have dy over dx is equal to negative sine, doesn't look like sine of x plus 5 all over y. Well, first thing we want to do is we want to get our x's on one side and our y's on another. So what we can do is you multiply both sides by dx. Let's go ahead and multiply this by dx over here and multiply this by dx over here. So when we do that, we're left with dy equal to negative sine of x plus 5 all over y times dx. Now what we can do is we can multiply both sides by y. Multiply both sides by y. So what I do is multiply by y over here and by y over here. So this y and this y simplify to 1. And we're left with our y on the left-hand side. Now we have y dy. Dy is equal to negative sine of x plus 5 dx. So now we have all our x's with our x's and our dy's with our y's. We can go ahead and integrate. Go ahead and integrate both sides, right? So if we integrate y, well, what do we get? If we integrate y, what we're going to get is, we're going to add 1 to the power. So our power is 1. So we're going to add 1 to the power and divide by our new power, which is 2. And add our constant c. From here, we're going to integrate the right-hand side. Well, we can take this constant out, right? So we have a negative right here. But once we take that constant, we're left with sine of x plus 5. Well, what we can do is some u substitution. So we can do sine of u, right? And our u is equal to x plus 5. So what is our du equal to? Well, if we take the derivative with respect to x, what we end up with is just 1. So if we solve for du, we get du is equal to dx. Well, do we have a dx? Well, we do. It's right here. Since we have a dx right there, you can go ahead and substitute it in with du. So we get sine of u du. That's what we're integrating now, right? So we have the negative integral of sine of u du. Well, what's the integral of sine of u? The integral of sine of u is just negative cosine of u. So we're left with just, after we have this negative over here, we have negative times negative cosine of u plus c. So we just got to replace our u. Well, we know what u is equal to. U is equal to x plus 5. We said that. We stated that. So we have cosine of, just put an equal sign here. We have cosine of x plus 5 is equal to, or my bad, plus c. So we're left with positive cosine of x plus 5 plus c2. If we go ahead and combine our constants, we get y squared divided by 2 is equal to cosine of x plus 5 plus c. Multiply both sides by 2, we get y squared is equal to 2 cosine of x plus 5. And remember, 2 times any constant, right, is just another constant. So we can just go ahead and write that as c again. And now we take the square root. Now when we take the square root of this, we're going to get y is equal to plus or minus. Remember, whenever you take the square root, you're going to get plus or minus 2 times cosine of x plus 5 plus c. So I hope these examples really helped iron out what it means to solve things by separation of variables, and maybe this is a bit more intuitive to you now. In the next video, I hope to go over a different method of solving first order differential equations.